Hi guys, welcome back to the channel. Today we're going to have a look at an Eddystone communication receiver. This will be an interesting one. Now the owner has told me that it just it has a problem, or it doesn't go. He wasn't real sure. He's had it for quite a few years, and he just wanted me to have a look at it and see what's going. So I thought, well, for all you guys out there that might have one of these, we might come across a common problem. Could be anything. So let's have a bit of a closer look and a bit of a look over this unit before we go ahead and get into it and see what is wrong. Okay, it's an Eddystone receiver, the model EC10. Now, I'm very unfamiliar with this. I have seen them in early years, but yeah, not familiar with using them or what's inside. So there we have an on-off by the looks of that, and RF gain. We've got AF gain, which of course is volume. We've got a BFO pitch for the shortwave listeners out there. So we have USB, LSB, and that appears to be just a variable cap inside, so it just varies the pitch to suit upper or lower sideband. Wave change. So our wave change goes from more or less down here. It goes from 550k up to 1500. Of course, that's the broadcast band. And then we jump to band 4, band 3, band 2, band 1. And band 4 begins at 1.5 meg, so it's a continuation of the broadcast band. The 3.5, 3.5 up to 8, 8.5 to 18, and 18 to 30 megacycles. And it looks like it's all continuous coverage. So even in amongst there, you would have CB frequencies actually in around the 27. The dial movement is incredible. That's geared down fairly well. That's certainly one thing that's working. If there's a little bit closer look at that on the tuning side, and that is just how well geared that is. So yeah, very, very nice. Some sort of vernier drive inside. It's geared and obviously very well weighted with a flywheel. Okay, let's have a look. See here, we appear to have inbuilt speaker, and the same on the other side actually, so I'm not really sure whether it has two speakers or it just works on one side. It's only a mono set. Now at the rear, of course, we have the standard 240 volt power, which this unit is. Seeing we're in Australia, it's all 240 here. Aerial, we've got a ground lug, A1 and A2 for obviously external aerials, and we'll see what that's all about later. I will try and download a manual on this, and we'll go from there. So down here, type EC10. Next port of call. I don't think there is nothing underneath. 4 rubber feet. That's it. So let's have a look inside here of what this compartment is. Probably a power supply by the look of it. Okie doke. We have a surprise in here. We have an OC169 and an RCA that I can't read. Little bit of a surprise in here. I didn't know about this one. Okay, let's take this one at a time. Okay, we have an OC169, obviously a germanium from a long time ago, and he will have a shield, which I'm not sure whether the further one is the shield or the collector. I'll have to look into that. But anyway, there's a surprise. Anything, and this one's an RCA. It's a 2N. I'll try and get a focus on that. 642. 2N642 RCA. Same deal. It will have a shield and emitter-based collector, or however they're arranged. We'll have to look this one up. 2N642. So we'll have a look at him. The plot thickens a little bit now as to what might be wrong with this radio. Yes, so a 2N642, we'll have to have a bit of a look for that fella. And OC169, now I don't know whether they've been replaced, whether they're faulty, whether they're missing from in here. I haven't been told too much about this. Hopefully that socket only goes in one way around and no one has connected it the wrong way around. No. So there is keyway somewhere. Ah, yes, on this end. There's a keyway there, nothing on that end. So it does only go in the one way. That's good. It's an S924, obviously, a 240 volt to whatever power supply. Put that aside. Now, I think it might be time to get the case off this old girl and actually see what is going on inside. We do have four screws here. There's a board mounted up the top, up in there, and there's a board mounted down the bottom here. And let's see what's inside. This does say made in Birmingham, England. So yes, she's an English radio, and hopefully we can still get transistors for this thing if that is faulty. Nothing's happening here. Nothing's happening there. Okay. Does the front come off? Does the back come off? Looks like there might be 2 points here where we put our screwdriver in, and yes, lever the back up. Okay. There we go. Right, guys. What I'm thinking here is before we go too far with this fella, this is what I'm using for the power supply. Now, apparently it's a 9-volt power supply according to the circuitry, the schematic diagram, so forth. Now, I'm just going to remove the cover on this. I'm going to check the output. We're using this for the supply. I mean, I could put 9 volts to it anyway, but I want to make sure that this is working okay. So this is where we start. Take the top off this. Make sure we've got 9 volts, no ripple, no noise or anything in it. Check the filter caps. So, yeah, originally it looks like a factory-built supply. Apparently, a lot of people have made their own for this because it more or less comes with a six battery compartment that goes in the back of this, so you can run it on batteries. But this is the AC power supply that, yeah, well, it's made by Eddystone. So yeah, this could have been bought with this. It could be an option. I'm not absolutely certain of all the history of Eddystone. I'm reading up on this. But anyway, we'll have a look inside this, do some voltage checks, make sure this is okay before we proceed with the radio. Now, I'm just assuming that this is where we start. 2 little nuts either end, and it looks like it is. And we'll just get this through a bit. Okay, well, I got to give you guys a little bit closer look on this one. Okay, look what we're looking at here. Selenium rectifier. Little transformer. Now, it looks like we've got a filter cap that's been replaced for certain. Looks like there may have been one under this little cover. Looks like there's one on here. Not real sure of the circuitry, but that's your positive that comes out of, no, that's your negative line that comes out of your selenium. The 2 ACs in, look at that, to the transformer. Negative is, of course, this is a negative rail radio, being germanium, and the positive actually goes to ground of the selenium. So that will be ground on that fella, and that which will be the positive, and the negative is your live. So that capacitor doesn't look real crash hot, actually. This one looks original, so we'll have to certainly inspect him. And we've obviously got a little 5 watt, or looks like a 5 watt Zener in there to regulate our voltage. The resistor is a 22 ohm and probably about a 5 watt by the look of it, 5%. Now from here, there's a ground, which is normal. There is this from the power supply, and another one here. Where does the grey go to? Okay, these are through fuses. So I've got an AC fuse that goes to the transformer, and a DC fuse, which is actually a 500 milliamp, that goes down in line with that fella there, which is your negative rail. So, yeah, the negative is fused by that fella. Okay, so we've got this fellow on this end comes straight from the transformer. Okay, I see. This is actually AC, goes into the radio, to the on-off switch, back to here, and turns the transformer on. And our ground is this fella here, and this one, which is positive ground, and our negative rail is that fella. So we've got those two, which is 9 volts. And the scary part, these go into the radio to your switch, which is on your RF gain control. Okay, we've got that worked out. Let's check out these fellas. I'm not real sure about this one. He looks a bit sus. And, well, this one, not real good looking up towards the top there, but we'll take this out and check him out. Okay, what we've got here is a 530 volt. And the end of him, the rubber end, is extremely hard. I would say That fella certainly needs replacing. And this fella is a 1000 mic 16 volt. Now, I'm not real sure what the originals were in this, but I think we'll put maybe two 1000s at about 35 volts back in here. This one on the output of the selenium before the resistor, and then after the resistor that we put this fella. Okay, we'll do that. Now, guys, what I had here, originally, apparently these were 1000 mics, according to research. I only had 1500s, just the radio fellas. What I've done is I want some longer leads, so yeah, a trick for you guys, I guess. I don't know whether anyone else does this, but I've just soldered some longer leads on him, bit of heat shrink, and I can use the caps I've got. Reason being, this one's got fairly long wires, and I can tuck these fellas where I want them. Also, keep the old spaghetti off these ones, so we can put it back without the danger of things shorting. By using these, we can also use the original clamps to clamp these to the case. So that was another reason why I used a little bit bigger cap, 1500s at 35 volts. Yeah, this fellow at 500 at 30 volts. He's out the gate. We're going to measure him later, just see what he is. Right, guys, so I've got the caps in, and as you can see, what I've done there is just mounted them under the old brackets. We have positive ground coming from the positive selenium, and negative of the last cap to the resistor, which is our battery line, which is a negative rail to the transistors. Just want to explain that for the people that maybe don't know a lot about power supplies or power. So yeah, our negative is our live feed, and the other side of the where it comes out of the selenium to the resistor, well, yeah, that's our negative side of this cap. So both negatives on the live rail. Okay, so we just did a little bit with a little bit of heat shrink, just to make it a little bit safer. So we'll put that on. I'm certain there'll be no other problems. We can't. We could test it by jumping that, but we're certain that's right. So we shall put the back on him, and then we'll get back to the radio and see why those two transistors are floating around, which incidentally doesn't match up with any numbers that are in that thing. So don't quite know what's going on there. We'll find out. But just before we move on, we'll check these caps out of the power supply and see what they're like. Now, this is a 1000 mic 16. So our negative, positive, there we got 1125. So from 1000, probably leaky. But anyway, it does have capacitance as such. We'll try this one, which is a 500. 570 is stable at, but yeah, I'm glad by the look of the end of him. Very hard, quite old. I'm glad we changed this fella. Okay, let's move on. Right, now we're looking at the bottom of this baby. Our tuned circuitry as such, our coils for the different bands. I think we'll start these switches very tight. Grease has gone hard. I think we'll maybe spray the pots and put a little bit of spray on the band chain switches so that we're back to square on a starting point anyway. We have a transistor in there, which is an OC170. It says 171 on the diagram, but we've got a 171 and a 171. So this is not the area, I don't think, where things have been changed, although that fella doesn't look real nice. He's a little bit corroded on top. So we also have a little electrode here that we'll look into along the track. He does seem loose, but no, he's not. Okay, we've got a diode up here, which is obviously detected D3. We'll have a look at the circuitry soon. So we'll start by just lubing things here to make sure there's nothing wrong with our switching mechanism. Now that he's cleaned up, we know that is working reasonably well. The area where I can possibly see some soldering done is in around this area here. Maybe a transistor here, but this is getting up towards the audio stage, so I can't see anything else. So let's undo these screws, lift this board up and see if there's any foreign transistors in here that shouldn't be there, and maybe do a little bit of testing around the audio output stage. Okay, let's see what we've got under here. Right. Interesting looking transformer there. Now here, this is our audio output, obviously. So this fella here, he looks foreign, which is, let's have a look. He's an OC71, so probably not. Let's have a look at the circuit with you guys. Okay, now that is TR7, so TR7 is an OC71. So we're looking here at the moment at that transistor, OC71. Then we've got an OC83, is it? 83 and an 83, I think. So the three outputs, and this one is an OC83, and they would be the original OC83s. Strange. Okay, back here, TR6. This is, gee, they don't give you much wire here to get this out. TR6 is an OC172 by the look of it. No, it's a 171. This one is an OC171, and this is an OC171. This is very strange because all those transistors are originals. Where did the two come from? Now, looking down in here, we have a little bit of solder activity down in around the RF there. So maybe these could have been changed. Just not real sure. There's a couple of caps, electro here, these three. Now I'm looking at little one like this that may be causing low audio or no audio to the output stage. We'll just see what he is. He's C63. So let's see where the audio gain is. Here we go. C65, not there. C63 is down here, which is on an AGC line. He could be causing problems, actually. So that fella would be very sus for low or no volume. Well, these fellas, yeah, maybe. What else have we got up here? We've gone up into the audio stage. That fella there, C75, I think, 100 mic. He may cause problems. Yeah, any one of these could cause problems. So I think we'll start just investigating or trying to locate where those transistors came from originally, that come out of it. But we might try and inject a signal with our Jenny back to the volume control here. So how about we go into the wiper of the AF gain and see if we've got any signal coming through here. Just see what's happening. Yeah, I'm just going to give you guys a little bit of a live view. C55 in there. Boy, that fella doesn't look real crash hot. I reckon that fella would definitely go. And of course, the one we were looking at there, C63, he doesn't look real crash hot. So a couple of places to start there. The rest, just give us a little bit more of a look at the board, a little bit closer look. The rest of it doesn't look that bad, but yeah, electros could be a major problem in here, which is no real problem to get it going. Okay, yeah, got him. So this is a little bit easier to turn around. Got the power supply connected, plugged in, turn him on, RF gain right up, AF gain, about halfway at the moment. Now, that seems to be our shielded wire that goes down to the volume pot, or the AF gain. So we'll hook onto that fella and we'll give him some 1 kilohertz tone. Like we're at 10 dBm there at the moment. We have absolutely no sound. So I'd say our audio is probably the place to start. Absolutely nothing there. So we'll trace back here, but what I have also noticed is there's a tiny little cap in here, a little electro that looks terrible. It's been leaking. So maybe, yeah, a couple of things back in towards this way. We might go to, let's have a look at the circuitry, shall we? Let's see what the next port of call will be. Okay, AF gain, which is volume, comes back here to the base of an OC71 TR7, so the base of TR7, which is this fella here. So let's see if we've got anything at the base of this fella. Now we can turn this around, or we can, an easy way to go to him will be he also connects to one side of R37 up there. So base there to R37. So let's find R37, which is an 82K, and go in on one side of him. Now, R37 is this fella in here. So I'll back this Jenny off a little bit. And let's see what we've got on there. Nothing. On this side, which may be, yeah, I think this would be him. Okay. We have a little bit. We have tone, but we certainly don't have much. Okay. And of course, nothing here makes any difference because we are skipping the volume control. Now, I don't know what the AF filter does. We'll no doubt find that out shortly. So, very, very low audio right there on the bass. Let's go one step further, shall we? We've got the bass. Let's go to the emitter. Now, what we've got here is in and out, which is this filter. This goes straight down to C78, and C78 is that little fella that looks terrible. Now, if he's in, he still goes to C78. Okay, I would suspect C78 is, oh, geez, sorry about that, people. In or out of the filter, comes down here and goes to C78, that little electro just there, which then drives your driver transistor. So this is your first audio frequency amp. Not real sure what the switch does. Switch is in a coil here by the look of this. Yeah, maybe a gain or yeah, we'll find out. So I would suspect C78 is a 1.25 mic. So we'll put probably put a 1 mic in there. And I would think we might have audio after this happens. Okay, let's see what we can do after we change him. This little fella, let's see what he measures before I put a new one in. Totally open circuit. Okay. I think we might have sound, maybe, after we replace this fella. 1.6. Should I put a 2.2 in? No, I think we'll put a 1. Got our 1 in there. Let's see what happens. We're still plugged into the mains. Turn him on. We'll turn this down. RF gain. And we still have no audio. But we have something very much louder on our switch. Okay. So let's go back and see. Have we got audio here? If it is, that's not very much. Okay, we'll take our Jenny back down. Let's see if we've got audio on our pot. We do. We do have audio on the pot, but not very much. Very little. Let's go back to the base of our TR7 and see what we've got there. We'll turn the Jenny back down, and that was on that side of the transistor, and we have, yeah, loudish, but of course that's going to make no difference. But it is better than what it was. That's on the base. Okay, so we might have to see what's on the collector. Okay, so we're on the base of this fella. Obviously, this has made quite a difference here. So let's go to the other side of him. Oh, yeah, we're on the base here. So let's go to the collector and see which is the negative side of our little cap that we just put in. So let's go there and see what we got. Back the generator off again. We don't have much. Don't have much. So we've got a little bit there. And then we come to the base. Yes, so that transistor is actually working. Got a bit of gain there. Volume, hardly anything. Okay, what's going on? What's going on? What else have we got in line there? So we have reasonable volume there. We come down here. We've got hardly any volume here. Now, what's going on here? We only go through here. Is this doing his job? Although we have more gain here at the base than on the emitter, which is good, means that transistor is amplifying. So let's go back. C74, it's a 0, 1. Yeah, then we're back to the detector. So maybe what's dragging this down is C63, this little fella that we saw originally. I'm going to change it anyway. So let's change it and see if it alters our gain. If we've got a leaky cap here, it'll be dragging our audio down on the pot, although we've still got low gain here. But yeah, let's change C63 to start with. C63, have him out. He's a 10 mic, nothing special about him. Let's see what he measures. 20. I'd say he's fairly leaky, this lad. Very leaky. Let's throw a 10 mic in and see how we go then. So this fella's a 10 mic, 63 volt. Should be enough voltage, considering there's hardly anything on it. It was just what we had. So there he is. Put in negative, positive this end. Okay, let's turn him around and see if we've got anything at all now. Still have nothing. Still got a click. Let's put our generator back on our pot. Very, very, very low. Now, I've got to work out, is this the point for the pot? I'm going to pause this. No, we won't pause it. Okay, goes to R28. R28 there. It's an 8.2K. That is definitely this spot here. So we're going onto this end. We go down to, what do we got here? Very hard to read this. 54, 22K. Anyway, C74. And then up to here where we were, the base of TR7. We'll just go back to the base of TR7. Yes, it's there. Base of TR7. So we got some there. Okay, we might do some voltage checks on TR7. I think this is the next thing. I do have some voltage charts here, so I think we'll do this. TR7. Okay, collector 4, base 0.9, and 0.9 on the emitter, 0.97. So yeah. Almost 1 volt on the base, which of course is high because it is germanium. Okay, TR7, 4 volts, collector volts. Let's have a look. Collector voltage, which will of course be a negative because it's negative supply. Can't, what else gets to him? Collector, which is R40. So this is R40 here. So we're looking at no voltage, and this end, no voltage. What's going on? Okay, let's just make sure I got a good ground there, which we didn't have. We got 3, and up this end we have 6.97. So we've got 3 volts here on the base. We should have 0.97. 0.97. 3. A little bit low. And this fella here, 6.9, say 7. On here. Yeah, that'll be probably about right. Okay. So voltage is not too bad. Let's go to TR8. We'll just check him out. Okay, TR8. 8.9, 1.5 on the base. 8.7, yeah, pretty close. Yeah, base, 1.4. Not bad. Now, we've got some caps in here. That is our volume. Why don't we have... I'm going to lift this fellow up and see what we've actually got on the pot wiper itself. Right, what I've done, lifted the lead, gone directly to the pot. That is definitely the wiper. Not a lot of gain there. Not a lot at all. Let's take him up. Oh, he's at 10 dBm, so there should be plenty of signal. We don't have plenty of audio. We don't have. The thing I'm going to change now is the audio just seems to be low gain. It seems to be working, but let's change these caps. There's 100 here, 100 up here, and there's another fellow in around here. One there, one there. And these are decoupling caps, so yeah, I think we'll just change these. Okay, let's try it again. On RF gain. And let's see what we've got. Ah, I can hear gain. I can hear gain. Let's back him off. Okay. We'll go into here. We'll go onto our pot. Got signal there. Yes, we have reasonably good gain. Right, okay. Turn him off. We'll reconnect back onto here and see if we've got the next stage working. No. No, we don't. We're just not that lucky. Okay, we're just not that lucky. Not that lucky indeed. Okay, so we've got another suspected cap up here at C55. All right, well, we know we're working. Let's have a look here. We know we're working here now. We've got good, we've got good things happening here. This cap, C63, which is that one that we've replaced. So you've got 66 and 55. So C55, 54, thought it was 55 up here on a rail. Yeah, I think we'll replace him. Looking very sus, extremely sus actually. And C66, 63, 65. Well, we got 66 up here on the main rail. Don't think he's causing a problem, but you might pay to check the main rail because we come through this 470 ohm resistor from up the end here. So yeah, we'll I think we'll just replace those caps. It looks like just a total cap replacement in this thing, so we'll just keep going with that. Let's try this again. And we still don't have any oomph in the whole thing. Let's have a look further down the track. Just a moment, I'll grab my chair because I need to sit down for this one. Let's try some voltage. Go in on there and grab a good ground somewhere. There we go. Right, where we were. Okay, we've got audio happening. Not much coming out of the OA90 that I can see, but let's check TR5. Let's check his, it's the third IF. Yeah, third IF. And then the detector diode, the OA90. So let's go for the TR5 and see if he's got correct voltages. If he has, maybe OA90, maybe, but we'll see. TR5, OC171, we'll see what's on him. Okay, what are we supposed to have? TR5, 7.5 and 0.7 on the base. So 7.5 on the collector, which if we can get in here, oh, hang on a minute. What feeds him? It's easier. Okay, what have we got? We got R29, which is this fella here. One side we've got 1.4, and on the other side, what do we got here? We got just a moment here. R29. It's 100 ohm. That's him. We have point 0.3. Let's see here. Okay, on the collector, 0.3. That's not real good, is it? And on the other side of that 100 ohm, the R29, we've got 1.4. Okay, let's see here. Let's see what's going on. R29, that should have, let's go to R30 up here. Coming through the transformer, we should have in around minus, it's on the rail, through 100 ohm. So, minus 6 or something. So R30, R29, let's have a look at R30 is this one up here. Let's see what's here. 3 volts. Let's see what's here. 1.4. Why have we only got 3 volts? Okay. R31, it's a 470 ohm. R31. Right, there's our rail. Minus 8.9 this side. Minus 3. Okay. Still could be this fella dragging it down. Every possibility. Oh, hang on. I think we found the culprit. I think it's this fella. What's he got on the base? Can we get in there? On the base. What have we got on the base? We've got 0.2. I'd say we've got a dead transistor. So, just making sure of things here. What are we on? TR5, 7.5 on the collector. And this one here should be 7.5. It is 0.2. Okay, so that by the sound of that, he's got a bad junction or something's gone wrong inside him. Okay, let's get him out. Okay, that's your shield, collector, base, emitter. Let's see what he's doing. If we look where he come from, we've got collector, shield, base, emitter. Let's have a look and see what my trusty meter says. It's an OC171, by the way, and it should be. Okay, we have him wired up for red, green, black. Collector, base, emitter. That should be him. Let's see what he... Oh, no, my battery's flat. Oh, why is it these damn things? They're always flat when you go to get them. Oh. Okay, let's charge him. Let's connect him up and then we'll try that again. Okay, well, believe it or not, I've found an OC171. Test's okay. So I'm just getting him in at the moment. Solder him in and see what happens then. Apparently an OC171, not many equivalents, and has a habit of shorting to the case, which I think was our problem, which is the shield. The shield is actually the case. Okay. Put him on there. Dab on there. And a little bit just on the bottom there. And let's see now what we've got. A few hassles with this fella, but anyway, it's all about repairs. Plugging him in. volume down, RF turned on. We have noise, but we don't have any operation. We do have a little bit of noise, so we've certainly got our RF noise, our audio amp noise, but let's get just there. Let's have a look at the voltage now. Okay, let's plug him on there. Now, 3.1, 8, and on this end we have 1.4, 0.2. I think we have another dead transistor. It did test, but didn't test real good. Now our supply is 8.9, drops to 6.7 there. The other side. Oh, hang on. We've got 6.6. We've got 6.6 on the collector. What have we got on the base? Nothing. Emitter's got 0.2. Collector, 6.2. Right, guys. Well, we're back. After a little bit of a break, I have replaced a transistor there with an OC171. Still not much go. Next transistor, OC171. No voltage on the collector. Now, these transistors have a habit of shorting the collector to the shield. So I've just unsoldered the shield. We have voltage here, which came up. Now, I'll just, if I can, show you a bit of what I mean here. Okay. Now, up here, if I can, where's a good earth point on this thing? There. We got collector of, okay, let's backtrack a bit. We're at this point here, the collector of T4. We've replaced this one. He's now working, but still no sound. We're back to here. We do have gain through here. We're here on the collector of this, which apparently is around about 4 volts, 3 to 4 volts, depending on where the RF gain is set. So there's nothing here and there was nothing here. What I've done is disconnected the shield that goes to ground from that transistor, from TR4, and the transistor is now working. We do have gain right to here. So we're, backtracking here. Doesn't look like these OC171s are a very popular little thing. Certainly not in my books. So what we've done, is just disconnected the shield. If we connect it, there is no voltage here. It drags this voltage here, coming from the rail, down through the transformer to the collector. It drags it down to 0. Lift it, and it goes back to 3 volts, or 3.6, which it should be on the collector. So now we're looking, and we have the right, we have about 1 volt on the base, which is normal. So now we're actually back here on this first IF. I this thing comes from that transformer, goes up to here, shielded cable to TR2. Now, is TR2 got a shorted shield? So we'll check him as well. So now we're underneath, we're on the other board. Now, that seems to be where this comes from. This one here goes back to the switch. So yeah, we have band selection here, here, and here. This is definitely okay. TR2 is an OC171. So now I'll just show you the voltage, which varies with our RF gain and goes, well, up to 2.3. You can't quite see that. It goes up to 2.3. As you increase the gain, it drops. So, and then we have gain here, which goes to the transformer, which comes over here. We're dead. This is dead. And this is the shielded cable that goes down onto the bottom board, just as I explained. Another thing that I have is a very old signal injector. Just a broad RF signal injector of noise. It's an old micron one, and it works like a dream. So we clip him on. We've got a push button here. We'll turn this down a bit. So we'll go to the collector. We have noise. We go to the base. We have lots of noise. So we know over here we've got noise. We've got noise on this side to that lead that goes down underneath. So let's chase to the next transistor. The next one. Okay, we're now underneath. And here's our transistor under here, which is OC171 TR2 written in there. Might give you guys a little bit closer look at this, because you might be fixing one of these one day. The rate the restorations are going around at the moment. Okay, this fellow in here. Now, this is our line, pretty sure, from up the top. So, quick and easy test is I'll throw the signal injector onto that point, and that's him. Okay, so now we're going to check out here what our collector voltage is on this transistor. I'll get my pointer, trusty screwdriver, collector. The collector actually comes, our voltage is actually TR2. Let's go back here, TR2, 6.5, okay, and 1.2, or thereabouts. Now, our collector voltage is coming from this center tap of the IF transformer, the first IF transformer. Now, that would be R18 on the top board, 100 ohm resistor, R18. So really, on this cable, there should be voltage. Yes, it's shielded, but there should be a voltage there of around about 6 volts. Let's check him out. We go in here. We've got 0.3 we've got 0.3. No voltage. Now, the other thing it could be is the transformer itself on the top board. Could be open circuit. Let's have a look. We'll pause here. We'll put it in a better position again. Okay, we're back up here. There's our point. And we have 0.3 volts. 0.3. So through a resistor. The resistor's over here. No, I'm not real sure where this resistor goes. Hang on a minute. There's our feed, which is 5.5, resistor here, 0.3. So that resistor is either very much open, or there's a fair bit of juice being dropped here because of a crook transistor, a shorted collector. So there's our resistor. These 100 ohm. You guys can't see that. There's our resistor up there. This is R18. Okay. R18 is there supplying juice to the transformer, which is tapped off and goes back to the transistor. R18, 100 ohm. Doubt very much whether 100 ohm. 0.3 on that side, and we have 5.5 on the other. So I dare say that transistor, if we lift the screen leg, we might have a goer. Let's see. I'll turn this off. Now, the transistor appears to be, let me get my bearings again here. There, 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 and there. Now, the second one is screen, which is that fella there. Let's lift that fella, and strangely enough, there's been some soldering around here, so don't quite know what's gone on. But let's lift the screen and see if he's shorted. If these transistors are shorted, we might find an equivalent. I've been told a BF126, I think. No, sorry, an AF126 may work. Let's lift that screen up. I say screen, but it's actually just a shield. It's the case of the transistor to reduce a little bit of noise. There. He's not touching. We'll go back and try this again. It's just one thing after the other. There's quite a few things wrong with it. Right. Let's see. And listen to that. We have noise. We have noise. This is good. And if we go up here, we might be lucky to catch an ABC station.
That they don't get to see each other before they get married. Whereas in arranged marriages nowadays, you 100% get to know the person.
And our BFO. Our BFO works. AGC.
300 222 702 is the phone number. I'd love to know if you've used a matchmaker or if anyone.
So there we go, guys. Now, if we measure on the shield, which is really supposed to be ground and certainly not shorted to the collector, if we measure that, and I'll put him just on the shield himself. Just got to get a good ground here. There we go. There's your voltage, 6.3. So now the collector has 6.3 base 1. So all is working with that transistor. There we go, guys. And I dare say the problem was with the very first transistor we changed, which is which fella? This was the very first one we changed. I wouldn't be surprised if, let's try that again, if our shield here was shorted to the collector here, and there you have it, 100 ohm from the collector to the case of the transistor. Well, in actual fact, it's a little bit different to the case. It's 8K. You go on to the collector, 100K, in around 100K, and the shield to the case, for some unknown reason, is 8K. But anyway, there should not be anything between the shield and the collector. And there we go, 100K. So that transistor is probably okay, providing we don't use the shield. Was showed this trick a long time ago, and it took me a while to cotton onto this at the moment. But anyway, that's an old trick for newcomers. We've certainly got to see how this thing goes. We might do a little bit of an alignment on this. So I do have the details on how to do him. So yeah. We'll go back up here to another local station, which is 1089 kilohertz. So if we go 9, 10, let's shove an antenna in. And not much in here. And now let's try a bit of shortwave. Up towards 3.5. No, not much up there. Okay, next band. Well, we'll turn the light off, because that light of mine generates a lot of interference being a switch mode. No. Well, I don't think we're going to get anything in here. We'll try and, once again, have to put up a bit of an antenna outside, I think. My little antenna here is not real good. You'd think I'd have a better antenna than that, wouldn't you? But anyway, the unit's working. So let's lift the shield on the transistor here that I've put in. Make sure, remove these shield wires on this one and the next one, and we can start piecing them together, getting ready for an alignment. Okay. Well, I thought we might split this video up into 2 parts. The radio is working, as you know. You've seen it working. Everything was going nicely. But really, I thought you may be interested in watching the alignment. We'll go through it a little bit more thorough. I have rounded up a full service manual, everything on the alignment details, voltages, transistor voltages, and the RF, IF alignment. Some of you guys may have one of these machines, so it may help someone out there. So I just thought it would probably be a better thing to do that in a separate video, and that way you get a little bit more of a handle on what's happening. Okay then, until probably next week, we'll do the alignment and our video will be up hopefully in about a week's time. Okay then, we'll see you then. Bye for now.